All right, so we're going to pick up where we left off. So I was talking about filling in to the function here. So I don't really need the inside parentheses. So I just basically have the fifth root of x plus 1 minus 1. And hopefully that helps us see the plus 1 minus 1 cancels. Then I just have the fifth root of x to the fifth power. Those cancel. And so all I have left is x, which is, by the way, what we're looking for. So turned out nicely. Awesome. On to the other version. So this one, the second one, I start with the f inverse function, which is the fifth root of x, but I'm just going to leave it blank basically because I'm going to plug in for x. Then I also have the plus 1 on the back. So that's my f inverse function. Then I'm going to plug in for the x. I plug in the f of x function, which was x minus 1 to the fifth power. I hope we can see pretty quickly that the fifth and fifth power are going to cancel. I have x minus 1 left over and still that plus 1 from the original function. Whoa, sorry guys. And the minus 1 and plus 1 cancel, and I'm left with x. So again, on the test, you must show both versions. You got to plug them in both ways. All right, number 7, graphing a cube root function. State the domain and the range. I'm going to shift back to red here. All right, so first of all, again, h and k. H is 3 and k is 4. Remember, h always does the opposite of what it looks like. This is going to be going or shifting right 3 and up 4. Then I'm going to rewrite my function. I'm going to say y equals the negative cube root of x. So basically, again, just ignore the h and k. When I go to do my t-chart here, this time it's a little different than what we did before because now we have a cube root. So I'm going to pick numbers I know the cube root of. Very nice. And then when I plug those in, I'm going to get, so I have cube root of negative 8. That's going to give me negative 2. Cube root of negative 8 is negative 2. And then don't forget the negative in front. So I end up with a positive 2. Then the same thing is going to happen when I plug in negative 1. I'm going to get negative 1, which is 1. Oopsie. There we go. And then when I plug in 0, it doesn't matter because it's 0. So I have negative 0, which is just 0. And then when I plug in 1, cube root of 1 is 1, but I still have the negative in front. So now it's negative 1 for my answer. And sorry about that. And then negative cube root of 8. And again, cube root of 8 is 2. Negative in front makes it negative 2. So I'm going to graph all those points. I have negative 8, negative 2. I'm sorry, positive 2, excuse me, negative 8, positive 2. Negative 1, 1, 0, 0, 1, negative 1, and 8, negative 2. And so that's my basis, my starting graph, and then I still have to shift all those points. I'm going to shift right 3 and up 4. So every point goes right 3 and up 4, right 3, up 4, right 3 and up 4, right 3, up 4, oops, one more, there we go. And right 3, I'm off the graph, and up 1, 2, 3, 4. Like that. And then again, nice smooth curve connecting these. Something like that. Beautiful. Not really, but that's okay. And onto my domain and range. Remember, cube root functions are much easier because they pretty much are negative infinity to infinity. And that's for both. We don't really have any stopping points, no start on the graph like we did on the square root functions. Okay, so then back to red again. We have h is negative 1, k is 2. Remember, h is the opposite of what it appears, so I'm going left 1 and up 2. Write my basic cube root function, y equals the 2 times the cube root of x. Build my t-chart, x and y, pick numbers I know the cube root of. Set to go. And again, I'm going to go through this one a bit more quickly. So y equals 2. Then I'm going to plug in cube root of negative 8 is negative 2. So I get negative 4 overall. Next one, I'm plugging in -1. Cube root of -1 is -1, so I get -2 overall. Then I plug in 0. Cube root of 0 is 0, so I get 0 overall. Plug in 1. Cube root of 1 is 1, so I get 2 overall. And plug in 8. Cube root of 8 is 2, so I get 4 overall. Put all those lovely points on the graph. So -8, -4, -1, -2, 0, 0, 1, 2, and 8, 4. So those are my points. Then I need to shift them, not to go to the next slide. Sorry, shift the points. We're going to go left 1 up 2, 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 and left 1 up 2. Then connect all the blue dots to build your graph. There we go. And again, domain and range, -infinity to infinity, -infinity to infinity. All right, on to the next one. We go back to red here. Identifying the transformation. We only have one change to the graph, and it's right there. That's going to go left. I'm sorry, excuse me. This is an H value, which means it's doing the opposite of what it appears. We are going right 3. Sorry about that. It's getting late. Okay, on to number 10. This one has a couple of things. We have an H value. So H is -1. We're going left 1. We have a K value. Erase that nonsense there. K value is 2, so we're going up 2. And then we also have this number in front right there, which is a vertical stretch because it is bigger than 1. Vertical stretch. All right, then on to number 11, we're going to perform the operation. This one says do g of x minus f of x. So I'm going to start with g of x. There's my g of x function. Then I am subtracting the f of x function. One thing that's super important to remember here is you have that -1 in front of parentheses. So we're not just combining like terms. First, we have to distribute that negative. So I get 4x to the 1/2 plus 2x to the 2/3 plus 9x to the 1/2. That's a 1/2 minus 7x to the 2/3. Once I distribute that negative, then I just go back and combine like terms. So I have matchy terms here. That gives me, really wants to go on to this slide. Let's go back. Okay, those two together give me 13x to the 1/2. Then I combine my other two like terms together. Don't forget the negative there. That gives me 2 and -7 is -5x to the 2/3. So this is the answer we're looking for. On to the last one. This one is basically find f of g of x. So I start with my f of x function. And I'm doing f of g of x. And I'm going to replace the x with parentheses. And that's where I'm plugging in my g of x function right in there. So I have 2x plus 5. Then I need to simplify. I have a negative exponent, which I remember means a fraction. So I put everything over 1. Then I would say, hey, I need that negative exponent to be positive. The way we do that is by moving it to the denominator. What we need to be careful of here is that we don't confuse that -1 with the 8's exponent, which happens to be a positive 1. So 8 stays in the top, only the 2x plus 5 moves to the bottom. And that, by the way, is the answer we're looking for. Thank you. Good luck on the test tomorrow.